Hello everybody, we're going to be starting lesson 8 where we're going to be making basic trig graphs. So you should absolutely be following along with both the calculator and the notes. In order to make a graph, whether you're talking sine or cosine, you are going to have an amplitude, which is the height of our graph. And the frequency will be a number in front of the x, and that's going to tell us how many full curves we see between 0 and 2 pi. So this is the frequency, and frequency here means what frequency means anywhere, how many. And the height is the amplitude. We are not going to do the C. On your paper, you'll see a C. We're not doing the C. And then this D is going to be called the midline. We're not going to worry about the midline until we get to lesson 10. Right now, our midline is going to be 0. The middle of all our curves is going to be 0. So for lessons 8 and 9, no midline. So this is the same for both sine and cosine. Tangent, however, is in a class by himself. Now, before we get into what these graphs are, let's take a look at the unit circle that's on your paper. Now, this unit circle is extremely important because every point, the x is the cosine and the y is the sine. You should be so tired of me saying this by now. So for 0 degrees, if we were to make the chart, that's on your paper. You already have this drawn in, so let's fill it in using the unit circle. At 0 degrees, cosine is 1, sine is 0. Tangent is sine divided by cosine. So the tangent of 0 degrees is 0. Now let's move along to 90 degrees. The cosine is 0, and the sine is 1. Now, tangent is sine divided by cosine. This is undefined, which we saw Friday. Now, that's going to matter a lot when we're making a graph. You'll see why. We keep moving to 180. My cosine is -1. My sine is 0. And my tangent would be 0 divided by -1 or 0. Then when we're at 270, we have 0, -1. So therefore, at 270 degrees, my cosine is 0, my sine is -1, and my tangent is back to being undefined, because -1 divided by 0. So with this table made, let's look at one graph at a time. I'm going to get rid of this up here at the top. Now, you can follow along on your calculator to make sure that you're graphing it correctly. On the calculator, you must put your mode back into radians. So hit mode and make sure that you're back in radian mode. Then we have to set our calculator to match our graphs. And if I match my graph to the unit circle, my unit circle has 0, it has 90, but radians, if you recall, are pi over 2. 90 degrees is 180 divided by 2 because pi equals 180. And so then there's my 180, which is now pi. My 270 is 3 pi over 2. And then my full rotation back to 0 is 360 or 2 pi. Now, the highest amplitude I'm hitting is 1 or -1. So let's just label our graph. And now after we made sure we're in radian mode, now we have to set our window. So when you hit the word window, you need to set your window to exactly what we have here. We have 0 for x minimum, and we have 2 pi for the x maximum, and we're counting by 90 degrees, and that again, the scale is how we're counting, and that would be pi divided by 2. My minimum y I have is -2, and my maximum y I have is 1. So now, if I go into y equal, and I just clear out what's ever there, and I hit graph, my calculator looks just like the paper looks. So let's put in first the cosine of x and hit graph. And you see almost like a teacup. Now, what this is doing is this. It's following the unit circle. First, cosine of 0 degrees is 1. Cosine of 90 was 0. Cosine of 180 was -1. Cosine of 270 was 0. Cosine of 2 pi was 1. And here is my cosine. Now let's talk about the labels I would have to have. Anytime I graph and write these underneath the graph, you would say for this, your amplitude is the absolute value, because sometimes the number beginning is positive or negative. It's always the absolute value. And this is 1 whole. My frequency in front of here, 1 whole. So between 0 and 2 pi, I have 1 full cosine curve. And the period, how long did it take to make 1 full cosine curve? The period was 2 pi. So here, following the unit circle, there's my cosine curve. Now, if I want to make my sine curve, I am going to use a different color. Let's just get rid of the purple for now, because sine follows the y coordinate on the unit circle. So now I'll use blue. If I'm now going to talk about y equals the sine of x, my amplitude is still 1, my frequency is 1, and the period will be 2 pi. The overall formula for period is 2 pi divided by the frequency, and that would be 2 pi over 1, which would give me the 2 pi. So now let's follow the y coordinate. At 0 degrees, sine is 0. At 90 degrees, sine is 1. At 180, sine is 0. At 270, sine is -1. And back to 0, or the full rotation, I'm back to 0. So here is my sine curve. This is 1 full curve between 0 and 2 pi. I see 1 full curve. My period is 2 pi, my frequency is 1, and my amplitude, going up or going down, it is a distance of 1. So there's my height. Now for the basic tangent curve. Tangent is so much different than sine and cosine when it comes to making the graph. So I'm going to just have to erase and draw this again. So when I'm drawing, I'm still going to have my 90 degrees, my 180, which is pi, my 270, 3 pi over 2, and my 2 pi. But tangent has some problems involved. If you look, tangent is undefined at 90 and undefined at 270. So that means I have asymptotes. We're going back to that word of asymptote. So at 90 degrees, I have this vertical asymptote where tangent is undefined. And at 270, I'm undefined. And if I look at my numbers, the tangent of 0 is 0. And if I were to look on the calculator, which let's do that, so this way this might be a little bit easier to follow how the graph goes. If we type in tangent of x and we look at the table, now I start at 0 and I go up. And then all of a sudden I'm down at -2 and I come up, up, up. And then all of a sudden I stop and I go back down to negatives. So if you're looking at those numbers, that's pretty strange, but it's really not. It's because of the vertical asymptotes where I'm undefined. So if I take a look here, at 0, I was at 0, and according to the table on the calculator, I was going up. But then I hit the asymptote and it stopped me dead in my tracks. So then I look at the table and I say, but now I'm growing from all the negatives, and then I hit 0 and I start going positive, and then all of a sudden I stop dead. And now I'm coming up, and at 2 pi I would hit 0. So tangent grows until it hits that vertical asymptote, that undefined, where again an asymptote you may not touch or cross. Then it starts all over again, hits the asymptote, stops, has to start all over again. And I stopped my graph at 2 pi. If I didn't, I would have just continued. So what do I know about tangent? So this is y equals tangent of x. Well, I know first and foremost it has no amplitude, because it goes continually forever. It'll get closer and closer to this asymptote, but it'll never touch it. It's working just like the asymptotes worked in exponents and logarithms. Frequency, it has no frequency, because the asymptotes stop it dead. The only thing it does have is a period. It has a period of 90 degrees to 270, which that's 180 degrees. Every 180 degrees, I can see a full tangent, which is coming up from negative and going to positive infinity. So the period is 180 degrees or pi. So the range, so the period is pi. The domain has restrictions where it is undefined, but for tangent, it has a range of negative infinity to positive infinity, because it will grow along the asymptotes. That's it on tangent. I really can't tell you more about the tangent graph. That's all we've got for tangent. So you'll notice on the rest of our packet, it's all about graphing cosine and graphing sine. So this is really, you might make 1 or 2 tangent graphs in this unit. Other than that, we're going to be graphing sine and cosine. Now keep your table handy, because I have to erase mine to have it fit. So if you notice, I give you a separate set of axes for each graph. So hopefully, you're not printing all these pages. In your notebook, sketch a graph for each one. So this way you can see how they're growing, and you'll start to see all the overlapping items that we need you to see. So if I start with now this next one, exercise 2. And on exercise 2, I have y is equal to 3 cosine of x. Well, here's my amplitude. My amplitude is 3. My frequency, my b, is right here. There's the B. It's 1. That gives me a period of 2 pi divided by the frequency of 1, 2 pi. Now, ladies and gentlemen, you absolutely have to have these labels on every single graph you do. If you don't do the labels, you lose half credit. Silly. Write the labels down. Now, if my amplitude is 3, that means on my graph, my y now is going as high as 3 or as low as -3. This now gives me the range of -3 to 3. I will always oscillate up and down for my amplitude. And here's my 90 degrees, my pi over 2, my pi, my 3 pi over 2, and my 2 pi. Notice I label everything, and I expect you to as well. So cosine, on our table, at 0 degrees, cosine goes to 1. But now I have an amplitude of 3. What that means is 1 times 3. That means I'm going to start at 3. Then I go 0. 0 times 3 is 0. Then I hit -1. -1 times 3 is -3. Back to 0. Back up to 3. Cosine begins and ends in the same place. So if I begin high, I end high, and halfway in between, I'm down low. If you look at the second example where it says -4 cosine of x, well, again, my amplitude, my frequency, and my period must be labeled. My amplitude is the absolute value, which is 4. My frequency is 1, so my period is 2 pi. Now, the negative, though, matters a lot, because when I make my graph now, I have to oscillate between -4 and +4. So I need to make sure I'm showing everything. And here's, again, pi over 2, pi, 3 pi over 2, 2 pi, and there's my x. So the negative now says that when cosine at 0 degrees started at 1, 1 times -4 tells me I'm starting down low at -4. That means I'm going to end low at -4. Halfway in between, which is my 180, I'm up at +4, and halfway between those points is when I'm hitting 0. Now 0 is that midline I mentioned. It's the middle. Just like here, it's the middle. So here, this graph is upside down, and it's upside down because this is considered a reflection over the x-axis. You should pause the tape right now and see if you can do the next 2 cosine graphs without me. All right, so hopefully you're back now and you tried them yourself. Let's see what happened. The next one was 3/2 cosine of x. And 3/2, if you use your calculator, that's 1.5. That gives me an amplitude of 1.5. So if here's 1 and here's 2, I am going to be starting at 1.5 and I'm going to be ending at 1.5. Halfway in between, I am down at -1.5, and I'm still hitting my zeros in the same place. This now gives me a range of -1.5 to +1.5. Then last one, -2 cosine of x, gives me an amplitude of 2, a frequency of 1, and a period of 2 pi. This is going to give me a range of -2 to 2, because I am now going to oscillate up and down 2. Now, the negative again tells me I'm starting down at -2, so I'm going to end at -2. Halfway, I'm going to be at 2, and my zeros didn't move. So here is the next cosine. Hopefully, the cosines went nice for you. Sine, we're going to have always 3 points on the midline. Notice cosine, we had our 2 points on the middle, the midline, on my zeros at 90 and 270, just like on the unit circle. Sine on the unit circle has 3 places where it is 0. It is 0 at 0 degrees, 180 degrees, and then back at 360. So when I look at exercise 3, and I have y is equal to 2 sine of x, well, my amplitude is 2, my frequency is 1, my period is 2 pi divided by 1, 2 pi, and if my amplitude is 2, my range is going to oscillate from -2 to 2. So when I draw my graph, again, must be fully labeled. I am going up to 2 and down to -2. 90, 180, 270, 2 pi, 360. Sine on the unit circle starts at 0. It's at 0 on 180, and it's at 0 on 2 pi. Sine goes up to its highest point of 1 at 90 degrees, but now I have an amplitude of 2. 1 times 2, 90 degrees, I'm up at 2. At 270, I was at -1 on the unit circle. And so -2 times that -1 brings me to -2 on my graph, and here is my first sine graph. If I have the second one, y equals 4 sine of x, the only thing that changed was the amplitude and my range. My amplitude now, I'm going up and down from 4, so that makes my range oscillate from -4 to +4. My frequency is still 1, and my period is 2 pi. So now when I graph this, and if you're using your calculator, you have to change your window and make your y go at least up to 5 on the calculator. But on my graph, I have to go up 2 and down to 4 and -4. And here again, label my axis fully. So now, from 0, I'm going up to 4, down to 0, down to -4, back to 0. And here is a larger amplitude. So my amplitude is the distance, whether it's up or down, from the amplitude. Now, why don't, again, you try the next 2. Pause the video, try the next 2 without me. All right, so now if I take this next one, y is equal to -3 sine of x. Again, I have this negative. My amplitude is still the number 3, absolute value. My range is going to oscillate between -3 and 3. My frequency is 1. And my period, 2 pi over 1, 2 pi. Now, the -3 is going to do what it did with cosine. If at 0 degrees, sine is 0. At 90 degrees, sine normally goes up to +1. But +1 times -3 brings me downward. I'm going down now. And then I am back to 0 at 180. Then at 270, I'm normally down at -1, but -1 times -3, now I'm up at 3, and then I'm back to 0 at 2 pi. So this now goes down, up, and down. It is the opposite way because of this negative. And lastly, y is equal to 1/2 sine of x. Well, this guy's not going to be as big because my amplitude is just 1/2. So my range is -1/2 to +1/2. Whoa, sloppy 1/2. And so my frequency is 1, and my period is 2 pi. So if I graph this guy, I'm going to actually stretch out my axis, because if I don't, it's going to be hard. So here's 1/2, here's 1/2. And then, again, my labels, 90, pi over 2, 180, pi, 270, 3 pi over 2, and full rotation 360, 2 pi. And this is a +1/2, so I'm going from 0 up to 1/2, 0, down to 1/2, 0. And here is my final one. So ladies and gentlemen, try your best on the homework, and good luck. Let me know if there's a problem, and I'll be more than happy to help.